Your lungs are flaccid. That means they do not have any muscle. They expand and fill with air and contract to expel air due to the creation of volume in the chest cavity with the movement of the diaphragm. Are you in band? Have you ever heard your band director say, breathe deep from your diaphragm? When you take a deep breath, you might find your chest expanding, and that's because your diaphragm has pulled down, which creates room for your lungs to fill with air. When you breathe out, your diaphragm pushes up and forces air up and out of your lungs. Your diaphragm is the muscle controlling it all. Your diaphragm is that dome-shaped structure you see right now, pulling down and pushing up, allowing your lungs to expand and contract. On that thought, many people think that your lungs are like two large balloons. And that's not quite right. Your lungs are actually much more like a sponge. That's right, a sponge. So here's the deal. A balloon is a giant area that holds air, whereas a sponge has these tiny openings and holes that can hold air. And when your lungs expand, they are much more like that. Let's talk about how your body brings that oxygen in. It begins with your nose and mouth. I've mentioned before that your nose and mouth are connected. You can clearly breathe in and out of both areas. And when you see here, you can see how the nasal passage and your mouth are connected to lead way into your windpipe, or what we call your trachea. But let's prove it. Let's take a look. You ever seen that before? Somebody bring something up and out of their nose? How about one more time? Just to really gross you out. There's a new trick to show your family, huh? All right. So here's the deal. As you inhale, oxygen gets pulled into your mouth and nose and begins to travel to your trachea, or what we call your windpipe sometimes. Your trachea has these ringed cartilage areas. Each one of these rings is made out of cartilage. Real quick, touch your nose. Touch your ears. See how they wiggle and move? They move more than a bone would. Well, that's what your trachea is made out of, or your windpipe. It has these cartilage rings that help hold the shape. Your nose doesn't just magically fall over, right? It holds its shape, but it's not super firm like a bone. And this allows the trachea to stay open, the windpipe to stay open so you can continue breathing. Then the trachea will then lead way to the bronchi. But here's another quick look at your trachea. This would be a down inward look, and you can see those rings branching off into these two branches because we have two lungs. Once again, here we go. We're looking at our bronchis, which are these little guys right here. They kind of look like the branches of a tree. Now, your bronchi, maybe you've heard of something called bronchitis. Here's one more quick look of how your bronchis are separated out into your lungs. And if you ever heard of bronchitis, that's an inflammation in those bronchial tubes. Sometimes we have mucus buildup in there. And so if you've ever had bronchitis, it hurts really bad, and it's caused by a bacteria. So we can heal it pretty quickly with some medicine. We can kill the bacteria off, and your body will slowly expel out that mucus. You'll cough it up. It's nasty and gross, but we can rebound pretty quick from bronchitis. But that's where the name comes from. It's this inflammation in those bronchial tubes. From here, we're going to go ahead and travel to the alveoli. The alveoli are like tiny little spheres at the end of the bronchial tubes. In fact, they remind me of like a little cluster of grapes. And those little clusters fill with oxygen and are connected to some capillaries. You can see those capillaries that carry the oxygen poor blood and those that carry the oxygen rich blood. And this is where the exchange happens, where we go ahead and transfer oxygen and carbon dioxide with the bloodstream. This is the really important part. This is where it's more similar to a sponge than to one giant balloon, right? These are like little teeny tiny balloons all over. Excuse me. So let's look at another animation of this. As we zoom in, you can see the little alveoli clusters and how those blood vessels have red blood cells traveling to them. And that's where that diffusion happens. Now, diffusion is a pretty remarkable thing. And so here's another animation where you can very easily see how the oxygen comes into the alveoli sacs. It then passes through the walls of the capillaries, hitches a ride onto those red blood cells, where then the red blood cells will then travel all throughout the rest of the body to deliver that oxygen. In fact, from here, they'll go directly to your heart. Your heart will then pump all throughout the rest of the body. And while those red blood cells are traveling, actually what you're not seeing is that they're also getting rid of the carbon dioxide through that same process of diffusion. So diffusion is the process by which material from high concentration or particles from high concentration are going to naturally move to areas of low concentration. So in this graphic, what you're seeing is this separating of the two colors, right, of these little particles and how they slowly separate and move so that way they're equally balanced on either side. They go from high concentration to low. And kind of the best way I know how to describe this is with a, let's see, fart. So you ever happen in class where you accidentally fart? Or your friend does, and you're sitting next to your friend and all of a sudden you smell something horrific and you start looking around, you're like, who did that? Who did that nasty thing? And then slowly the kids around you begin to catch on because they're smelling it too. Until finally, all the way to the other end of the room, everybody is smelling the equal stink. It's gone from an area of high concentration, because you were sitting next to that kid, all the way across the room to low concentration, because in the beginning they couldn't smell it. They were the low concentration. And so that fart equally dispersed throughout the room, and everybody had to suffer the stinky, terrible, smelly kind of smell, right? We've probably all experienced that at least. So you can understand how high concentration moves to low concentration. And that same thing happens in your bloodstream. So if we jump back, another quick example would be if you've ever dropped food coloring into a cup of water, you never have to actually mix it. It'll slowly diffuse throughout the entire container of water all on its own because of diffusion, the high concentration moving to areas of low concentration. And that's what we see in the alveoli. So we see the high concentration of more oxygen in the alveoli sac, less in the bloodstream, and it slowly diffuses out to create what we call equilibrium. And that's a very natural process that your body undergoes, not just in the alveoli sacs, but in many other cellular processes as well. And that's a general overview of the respiratory system.